first page, we're like, okay, we're graphing. Hang on a minute, Hardy. Okay, so we're graphing. Here's my graphing notes. Where's something? Oh, there we go. Something that kind of looks like these. So page 2 of my notes would be helpful. Okay. So when we're doing vertex form, might as well start with the first one here, because that way I can kind of have this to help me. I can find my vertex right away just by knowing these two values. But the one kicker is this number is the opposite of what h actually is. So we switch the value on what's in the parentheses and keep what's outside. So -3, -4. Whoops, that's not -4, Hardy. -3, -4. There we go. So I've got that piece. Name the axis of symmetry. The axis of symmetry is just the x value, your vertex. So x equals -3. And we'll get that drawn in there once we get our graph made. Now, am I worried about mins and maxes right now? Nah, I guess I'm not, to be honest. So we're going to that for right now. And so now we're going to graph it. So we chatted before about how you can go to the calculator. We can kind of play a pattern here. I have a feeling, and we're going to do this. Let's do this. Let's have everybody do this, because my honors class, we were doing weird stuff last hour, and I bet you your calculators, half of them are messed up. If you go to Zoom at the top middle, Zoom number 6, please. That will get you back to a normal looking graph when we start doing this here. So a little Zoom 6 action. Whoops, I don't need to be down there though. So I'm going to type this in. We're going to keep life simple. Make sure all your signs are good, that the 2's a negative, the little 1, 4's a minus. Calculator gets picky. If I want to look at the picture first, I can. Okay, it's opening down. That's good to know. If my calculator stops thinking. Now I want to get my vertex in the middle of my chart. And again, the reason for that is, number one, you're going to know you did the vertex right, because you're going to see the same numbers above and below with the symmetry. So once you have that, we really just need to plot some points. We'd like to get 5 points if we can. Sometimes you may only get 3. It depends. But we're making curves. And once we have that vertex in place, we can get our axis of symmetry in there. Now, I am going to ask one question here that I know is not on asking you for, but I'm thinking ahead. If I asked you, and I'll only do it on this first one, and no, you don't have to do it on every one after it. If I asked you to do domain and range on this, ooh, Hardy, why you got to do that? Okay, so here's the thing. If I'm doing domain and range, anytime you have a parabola, it doesn't look like this is still going out to the right, excuse me, and out to the left, but it is. Whenever you're doing a parabola of any type, your domain is always going to be infinite, no matter what. Opens up, opens down, shifted, stretched, doesn't matter. It's always going to be that way. My range, remember, is my y's from the bottom. The arrows are going down this time, so my bottom's negative infinity, to the top, the y value there. So just something to consider, because when we get to the quiz preview tomorrow, that's one of the things you're going to see, is domain and range are going to pop back up. So again, page 2 of the notes will give you examples to work with as you're trying to work through some of these. And like I said, I'm going to bounce a little bit because I want to make sure I touch on one of everything. It's kind of your last 2 days preview here. So I'm going to keep bouncing a little. Ooh, standard form. Okay. Let me bounce to the next page. I'll come back to a couple of those. So I get to my standard form. You're like, okay, Hardy, where's this? Let me look in my notes again. Okay, standard form. Standard form's on page 1 of the notes. It's the very first thing we did. So if I do, let's see if I can do one of these, if this is going to work. Oh, it's going to be close. Well, heck. Okay, we'll just talk for a minute. This one, I got to figure out the vertex, at least the x value. So I got that little tiny formula right there, this negative b over 2a thing. So, let me get back up a little bit here. So on standard form, this is how we're going to find our vertex. And this b and c thing, b is the number in front of x, a is the number in front of x squared, and if we needed c, that's the number that's on the end by itself. And again, we did this on your note page as well. So the opposite of b, so the opposite of 6 is negative 6, over 2 times a. That should be the only calculating I have to do on this problem. Once I get that, I'll grab my calculator. I'm going to type in my equation. And again, if you're still stuck on how did you get the squared, where's the x at, I can absolutely help with that stuff as we're going through here. And if I pull up my chart, second graph, and get negative 3 in the middle, before I just write the number with it as my y, make sure you're seeing those same numbers above and below. And if you are, you've got your vertex right. So we're good there. My axis of symmetry is x equals negative 3. It's going to be going right through my vertex. And now to get my other points, I'm seriously just going to pluck them right off the calculator. So negative 4, 3, negative 2, 3, negative 1, 6. And I'm just going to make it until I run out of room. I've run out of room. Get my value in there. So with standard, that's the only thing that I'm really going to have to play with before I can get all the rest of the info that I need. And I'm going to do it one more time just because this one's going a different direction, and I want to make sure you got a good one of each. Domain has not changed. That's the easy one. Range, I just got to keep stressing myself. It's bottom to top when I'm doing this. So here's my bottom, but it goes up forever. So that's one thing we're trying to keep an eye out for. Now, the other graph type that we did back on the first day of kind of playing with this unit. So we've done vertex, we've done standard. Not a whole lot of math we've had to do so far. The ones that we're going to do the most math for is about to come here. I didn't put any of them on the sheet. Oh dear. Well, I'll do another standard then since I screwed that up. Let's do number 11. I can't believe I forgot to intercept one. It happens. All right. So number in front of x squared is negative 1. B is negative 4. If I needed a C, I guess it's 0 because I don't see one there. So again, if I'm trying to figure this out, we're doing the opposite of b over 2a. So the opposite of negative 4 is positive 4 over 2 times negative 1. So 4 divided by negative 2 is negative 2. That should have me well on my way to getting my vertex. Now we need negative 2 in the middle. And again, as long as I see the same numbers above and below here, let me get out of the glare, I'm doing the right thing. So negative 2, 4, all right. My axis of symmetry is x equals negative 2, because again, that is the little foldable line going right down the middle through my vertex. And the chart's going to tell me everything else I need. So negative 3, 3, negative 1, 3, 0, 0, negative 4, 0. We've got what we're looking for. Get that set. So I guess we're going to be waiting for vertex form. We're going to be waiting for the review because I went bonehead and didn't put it on here. I must have skipped that sheet somehow. So the other thing that we've done since the beginning of the unit is the applications. So when we did those yesterday, we were talking about all these button presses and all this stuff, and I said, okay, I'm going to get you a help sheet to help with that. So, do I need to go back? Oh, I thought I needed to go back for a minute. Okay. Okay. I was going to say, I can go back. I'm willing. Okay. So, what I'm going to do, well, no, 7 was part of what we were supposed to be doing yesterday because there were the 3 problems that are identical to the 3 that we'd done together. So I'm going to start on 9 because that's just what I want to do. And I kind of had put the directions on there, but this new help sheet's better. So a couple of reminders before we get into these. Okay, time is x, height is y. Just saying. So, for instance, the height in feet of a firework at any time in t seconds during its flight can be estimated using this formula. You're like, okay, after how many seconds will the firework shell land? How many seconds, okay, I'm looking for an x value, land on the ground? Our ground, if we're looking at a graph, is the x-intercept, is the x-axis. So, I'm going to grab my calculator. I'm going to type this in, and I'm not going to use t, I use x. So if I want to look at the picture for a second here, let's see. So you're like, Hardy, it crosses the x-axis twice. What do I do? Okay, we got to use a little bit of common sense here. How many seconds will the fireworks shell land? That's like negative. Negative time does not make sense unless we're doing like the Matrix or Back to the Future. We're not doing that. So that's what I want. I want that stinker right there. So to get that, I am going to get out my handy-dandy new help sheet. And we're going to try, there we go. We already taped the equation into y equals. So zoom 0. Let's zoom fit. Okay. So now my job is, since I'm looking for the x-intercept, I'm going to do second and trace, and you've got to pick the right one. I want 0 because I'm looking for the x-intercept. So there's my little blinky guy. There's the value I want. You can only use the left and right arrows to try and get over to that intercept. We're going to get as close as we can here. That looks pretty close. So once I'm there, we're going to use the left button, and it says left bound, the left button 3 times, and we're going to hit enter. And there's this little faint line here, this border that shows up, and if my cursor wasn't on it, you'd see a little arrow with it. Once that happens, we're going to use the right button, because it says right bound, it's another hint. 1, 2, 3, I'm back where I started. 4, 5, 6. And we're going to press enter again. And there's these 2 little arrows that are pointing at each other saying, okay, it's in here. We press enter one last time. And the x value that shows up, this 5.09, is going to be how long it takes for that fireworks shell to land. So all I've got to be able to do is figure out what thing I'm looking for. What's the initial height of the firework? Okay, hang on a minute here. Hang on a minute here. Page 3 of the notes. Starting height is h sub o. H sub o is the number on the end. Number on the end. 12 feet. You're like, just take the number on the end every time? Just take the number on the end. What's the maximum height of the firework? Okay, let's bring this back in. We're still on the same picture, but I'm looking for something different. Now I'm looking for the maximum. So, well, how do I do that? Well, let's see. We already zoom fitted. We don't have to do that again. Second trace, number 4. Again, I'm going to use the left and right arrows to try and get as close to the top. Yeah, that looks pretty good. As I can get. And we're doing the exact same process again. So left arrow, 1, 2, 3, enter. This time you can see the little arrow there a little better. Right bound, right arrow, 1, 2, 3, 4, 5, 6. And when we get to the maximum, now here's where you got to be careful. It's not saying when did it get there. If it asked me for when, it would be 2.25 seconds, because x is time every time. That's not a bad thing even to write on your application help sheet, like x is time and y is height. I want the y value. 32.25 feet. Because height is always y. I might ask you for both. I might ask you for one. It depends. So that's a pretty good idea on there, but I do want to do one other one. I think I'm going to do number 2. I'm going to look to see. Is that the one I want? No. I'm going to a straight max problem. Let's flip over. And yes, I do have a key of this up front if you want to check something. Okay, let's do number 3. This equation gives the height of a rock in feet above the ground at t seconds after the rock is thrown upward. How many seconds after the rock's thrown will it reach its maximum height? The height is the y value of your maximum. The seconds is the x value of your maximum. So let's get our new expression in. So let me get my help. Just a second here. There we go. So zoom 0. Here we go. There it goes. Joink. So I get that in. And I'm like, okay, I want the max. So second trace maximum. So we're going to get as close as we can to the top. Yeah, I think I'm there. Left. 1, 2, 3. Enter. There, I can really see my arrow this time, that little border arrow. Right. Right bound. 1, 2, 3. 4, 5, 6. And one more enter. So again, the height is here, so like 26.1 feet. The X over here is your time, 1.06 seconds. I've got to keep those straight. I can't flip them. That wouldn't be the right answer. So that's kind of where we're at with things. When we hit the preview tomorrow, there's a couple other things I'll talk about. But what I want you to do is keep working on this page 9 and 10, and then working at least on odds or evens, I would say. So let's say this. Let's say pages 3 through 5, odds or evens, really doesn't matter. And page 9 and 10, the rest of them, there's only 3 left. Bless you. So that's going